Yeah. Good evening, everyone. आवाज आ रहे हैं? So last class we discussed about different types of ocean deposits, right? And coral reefs, and then oceanic circulations, and the currents of Atlantic Ocean. यहाँ तक बात हुआ था. So oceanic deposits are of four types. The one which is from land, they are called as terregenous. From the water, hydrogenous. From the organisms, biogenous. From space, cosmogenous. Okay, so we know about the examples. One of the important oceanic deposit is coral reef. Coral reefs are the symbiotic relationship between coral polyp and zooxanthellae algae. So that symbiotic relationship results in the establishment of a ecosystem which provides habitat for a very wide range of organisms. The conditions in which these coral reefs develop: number one, temperature of about 20 degrees Celsius. Okay. Number two, depth up to 200 to 250 feet. Okay. Third, sediments free. Fourth, salinity should be average. Fifth, platform on which they can grow. So because of all these conditions, the coral reefs are limited to 30 degree north and south along the continental shelf, and minimal along the western coast of the continents because of cold ocean currents. Okay? So अभी तो समझ आया होगा why we have the cold ocean currents along the western margins of continents, right? So यहाँ पर तो देखो, it's always the cold ocean currents here. Okay, तो यहाँ पर cold Canary current हमने mark किया था ना? So that is, it is because of that. So along the western margin, so there is lesser proportion of coral reefs. So that is about the distribution. Then types of reefs: fringing reef near to the coast, barrier reef, a thick barrier, wide barrier, slightly away from the continental coast with a lagoon, and atoll is a circular coral reef, right? So these are the different types. And then coral bleaching is a phenomena where the corals start to lose their coloration due to the expulsion of the algae, zooxanthellae. And the conditions which supports the coral reefs, if they are disturbed, then that results in the coral bleaching. Okay, so large scale events have happened in the recent times, and we have lost a major part of the coral reefs. So climate change and global warming is one of the important factor in that context. Next, oceanic circulations. So there are various different factors which are responsible for the continuous movement of water within the ocean. The most primary factor is wind. Wind causes the surface water to move, and it will push the water in a particular direction, and once it starts to move, the difference in the temperature, salinity and density and other characteristics will cause the water, this moving water, to take a particular direction. They are guided by the coastline. They are also influenced by the presence of Coriolis force, right? So because of that, it will start to take a movement all across the world, and it will develop a fixed pattern, right? So the factors are important. इसके ऊपर direct questions आ गया. Okay, first one is wind, then coastline, the differences in temperature, salinity, density, and then Coriolis force. Okay, so and then we discussed about the ocean currents of Atlantic Ocean. Okay, so within Atlantic Ocean, we have the north equatorial current, south equatorial current, counter equatorial current, or equatorial counter current, both are same. The north equatorial current merges with the northern branch of south equatorial current, and together it moves towards the Caribbean islands, gets divided into two branches. One branch moves towards the east, which is called as Antilles current. Other branch comes inside the Caribbean Sea and then comes into the Gulf of Mexico, comes out and joins the Antilles current. Together it is called as Florida current, and the Florida current moves along the eastern coast of USA, and that is called as Gulf Stream. After crossing the Newfoundland Island, it totally undergoes the deflection towards the right side and crosses the Atlantic Ocean from west to east, which is called as North Atlantic Drift. It gets divided into two branches. One moves towards the south as Cold Canary Current, which will join back the circulation. Another moves towards the north as the North Atlantic Drift or Norwegian Current. Okay, so in between two cold currents will join, one along the coast of Canada, which is Labrador Current, another along the eastern coast of Greenland as East Greenland Current. So in between, because of the continuous circulation of water here, यहाँ पर तो पानी कैसे continuously circulate होते रहता है ना, so it results in the formation of gyre. ठीक है, and at the center there is a sea. कौन सा sea? Sargasso Sea. ठीक है. So बताइए अभी doubts. Exceptionally high salinity, that is exceptionally high rate of evaporation. So because see, the overall rate of evaporation is high and the amount of water is less, है ना? Precipitation वहाँ पर नहीं होता है ना? At 30 degrees there is no precipitation. हाँ. So other than that, see, there are other local conditions which will decide the the rate of salt precipitation and the rate of amount of dissolved salt. ये सब तो decide करता है. It is not like a open ocean where there is a regular mixing up of water. Most of the high saline water bodies are inland, which is surrounded by land everywhere, which is cut off from the other water bodies where there is no mixing of water from anywhere else. So all these factors would decide. Yes. साउथ अटलांटिक का बात करेंगे, अभी रुक जाइए. नॉर्थ अटलांटिक का बताइए. विल कम देयर ऑल्सो, आगे आएगा अटकामा डेजर्ट के बारे में. और जो अभी तक बात हुआ है उसका बताइए. सो रेस्ट ऑल क्लियर? ठीक है. एनीथिंग रिलेटेड टू द करेंट्स ऑफ अटलांटिक ओशन? सो करेंट्स तो अभी शुरू किया है, आगे बहुत टॉपिक है ना, तो वेट करो थोड़ा सा, आ जाएगा. So rest all clear? Warm है. All equatorial currents are warm. ठीक है. So even the counter equatorial current is also warm. It is because of direction of trade winds. It is the trade winds which are pushing the equatorial current from east to west. Simple. Opposite direction में आने के लिए winds नहीं है. It is just the merging of both the currents towards the western part causes a generation of counter current. Okay, थोड़ा सा पानी बाहर मतलब वापस आना शुरू हो जाता है. That becomes a counter current. Otherwise, that is north and south equatorial current. ठीक है. चलो. So next, the currents of South Atlantic Ocean. ठीक है. So we'll follow the same thing. आप map में mark करते जाओ, and in the next page you should just keep writing the names of these currents, and if there's any extra information you can just keep writing as it is. There is no separate notes here. So you have to listen to me carefully. So this is north equatorial current, south equatorial current, and then counter equatorial current. So I told you the south equatorial current gets divided into two branches. One moves towards the north, another moves towards the south. So this branch which is moving towards the south moves along the coast of Brazil as Brazilian current. Next one, Brazilian current. It is just the southern part of south equatorial current. So this is Brazilian current which is moving along the coast of Brazil. So coming from the equator, it should be warm current, right? And it is moving towards the pole, so definitely it is warm current. And if you observe this closely, the coast of this South America goes in this direction, right? However, the current will not follow the coast here, because as it starts to come towards the lower latitudes, it will start to undergo totally deflection towards the left side. Two reasons: one under the influence of Coriolis force, another under the influence of westerlies. The entire current totally turns towards the left, and it will join one of the strongest current in the world. One of the strongest current in the world, which is continuous, and it covers the entire Antarctica completely. Like this. Okay, it continuously moves around the entire Antarctica, the continent of Antarctica, without any interruption, without any discontinuity. So, what is the reason behind that? Yes, because of the absence of land mass. So, this is our continent of Antarctica. So if you see, this is 30 degree. Okay, this is almost 30 degrees, and this is 60 degrees. Okay, roughly मान लो. So between these two, we have the strongest wind system in the entire planet. That is, what is this? Wind system. कौन सा wind system है? Between 30 to 60 degrees south. Westerlies. Right? So these westerlies continuously blow because there is no obstruction here. There is no land mass here. That is why they are called as roaring 40s, furious 50s, and streaking 60s. And because of the continuous movement of westerlies around this, it will also push the water in the same direction. It will continuously push the water in the same direction, and because of this, there is a generation of a current which continuously circulate the continent of Antarctica like this. It continuously circulates the continent of Antarctica. It is a warm current or cold current? Cold current, because the temperatures are very low. Okay, it is near to Antarctica, temperatures are very low, it is a cold current. And this current is what is called as west wind drift. It is called as west wind drift. Okay, so it is a oceanic current under the influence of westerly wind. That is why it is called as west wind drift. It continuously circulates the continent of Antarctica. Okay, there is no break, there is no discontinuity at all here. So that is what is west wind drift. So west wind drift is one of the strongest cold current in the world, and it circulates continuously around the entire continent of Antarctica and also the part of Pacific Ocean, Atlantic Ocean, Indian Ocean. All of them are influenced by the west wind drift. That is why this cold Brazilian current, sorry, the warm Brazilian current, as it turns towards the left side, it will come under the influence of the west wind drift, and even this becomes cold. This is which current? South Atlantic drift. Upar the North Atlantic drift, and if you remember, that was warm current. So South Atlantic drift became cold current because it is under the influence of west wind drift, which is a very strong current. It will join the west wind drift, and that becomes South Atlantic drift. South Atlantic drift. Now a part of it turns towards the north, and it moves along the western coast of South Africa. Okay, southern part of Africa इसका western coast के तरफ में जाता है, and this is what is the cold Benguela current. The cold Benguela current. The cold Benguela current. So why it is cold current? Because it is coming from the polar region towards the equatorial region, and it is also part of this cold west wind drift. A part of this current is moving towards the north, and that becomes the cold Benguela current. And because of this, we have the desert Kalahari desert and Namib desert. Okay, this is Namib desert and Kalahari desert. Okay, so this is also one of the driest desert. And here you can see the currents are continuously circulating this part in a counterclockwise direction. There it was clockwise direction, here it is counterclockwise direction. That results in the formation of another gyre here, but in the opposite direction. Right? So this is another gyre which is generated in the South Atlantic Ocean. So South Atlantic Ocean का तो बहुत simple है. We have the South Equatorial Current, which gets divided into two parts. One moves along the coast of Brazil as Brazilian current, which is warm current, and it starts to turn towards the left under the influence of westerlies and the Coriolis force, and it joins the west wind drift, and a part of it turns towards the north as the cold Benguela current, and the cold Benguela current joins back the South Equatorial Current, completing a gyre here. ठीक है? In addition to this, there is another cold ocean current which flows near to a small island here. Okay, this is South America. South America के continent के बगल में there is a small island. Okay, what is this island? Falkland Island. Okay, it's a Falkland Island, and this current blowing between South America and Falkland, it is called as the Falkland current. Okay, it is the cold Falkland current which is moving towards the north, and it joins the warm Brazilian current. It will join the warm Brazilian current. ठीक है? So any doubts here? दूसरा तो वेस्ट, यही वेस्ट विंड ड्रिफ्ट में चला जाएगा. A part of it moves towards the north, rest it joins the west wind drift. हाँ, हमेशा कोस्ट लाइन ही नहीं होता है ना. सारा फैक्टर्स साथ में होगा. सो जो सबसे ज़्यादा डोमिनेंट फैक्टर यहाँ पर वेस्टर्लीज एंड कोरियलिस फोर्स है. सो उसको अपोज करते कोस्ट लाइन के सामने तो नहीं जा सकते, पास में तो नहीं जा सकते. ठीक है. टेम्परेचर डिफरेंस ड्राइव करते हैं उसको. सारा करंट्स मूवमेंट लोकल डिफरेंसेस, लोकल टेम्परेचर डिफरेंसेस के वजह से होगा. सो मेजर करंट्स तो होगा. सो अंडर द ग्लोबल सर्कुलेशन लोकल छोटा छोटा करंट्स जो भी होगा वो लोकल वेरिएशन की वजह से ही होगा. ओके उसका सब सारा करंट्स का कारण याद रखने का जरूरी नहीं है. सो नेक्स्ट द करंट्स ऑफ पैसिफिक ओशन. कोई नाम नहीं है. Currents of Pacific Ocean. So here also the same, we have the north equatorial current, south equatorial current and counter equatorial current. They are driven by the trade wind belt. So towards the north of equator we have north equatorial current, towards the south of equator we have south equatorial current, in between counter equatorial current in the opposite direction. The north equatorial current coming towards the western Pacific Ocean. So there is a huge landmass, the island and archipelago, all of this part. So that will divide this and cause it to move towards the north. It moves along the coast of Philippines, and as it comes to the higher latitudes, it takes a total right turn. It takes a total right turn and moves along the coast of Japan, and from here it starts to move towards the east backwards, and it crosses the Pacific Ocean completely from west to east. So now this part, the north equatorial current turned north and along the coast of Philippines and Japan. So this current has a specific name which is called as Kuroshio current. Kuroshio current. Okay, along the coast of Pacific and Japan. It's a Japanese word, Kuroshio. So it's a warm current moving along the coast of Philippines and Japan. So this current turns totally towards the right side. As it comes towards the north, it totally turns towards the right side under the influence of westerlies and Coriolis force and crosses the Pacific Ocean from west to east, and this is called as the North Pacific drift or current. Okay, same pattern. वहां पर जो pattern था यहाँ पर भी यही होगा. So just the difference is that the Pacific Ocean is much more wider, right? So here the land divides into two parts. One moves towards the north as a warm current, another moves towards the south as cold current. The cold current is the cold Californian current because it is moving along the Californian peninsula. Okay, along the Californian peninsula it becomes a cold Californian current. Along the northern part it is moving towards Alaska, it becomes the warm Alaska current. Okay, it comes like this, and that is what is called as the warm Alaska current, and it has the same impact as that of the Norwegian current or North Atlantic drift. So what is the impact of North Atlantic drift or Norwegian current over the Western Europe? It will keep the temperature warm. It will keep the ports ice free. The same temperature, same condition is here also along the western coast of Canada and Alaska coast, Alaska southern coast. The same, the ports are ice free. There is slightly better winter. It is not too harsh winters. So that is why this is also British climate. ये भी British climate ही है. right? So British climate is cool temperate western margin. This was cool temperate western margin, right? So फिर अलास्का करंट ऐसे ही ऊपर जाके ऐसे डिस्पर्स हो जाता है, यहाँ से पानी मिक्सअप हो जाता है, डिस्पर्स हो जाता है, ए पार्ट ऑफ इट मूव्स इनसाइड आर्कटिक ओशन, फिर वहां पर वो ज्वाइन हो जाएगा. So the Californian current will come back and join the north equatorial current, and this results in another gyre here. So यहां पर भी एक gyre है, ठीक है, सेम ही है, नॉर्थ पैसिफिक ड्रिफ्ट. ठीक है, कौन कौन सा करंट था इधर? नॉर्थ इक्वेटोरियल करंट, एंड देन कुरोशियो करंट, नॉर्थ पैसिफिक ड्रिफ्ट, एंड देन वार्म अलास्का करंट, कोल्ड कैलिफोर्नियन करंट. कैलिफोर्निया से वापस आ गया फिर. सो नाउ देर आर टू कोल्ड ओशन करंट्स हियर. ओके, ये वाला पार्ट देख रहे हो, जापान वाला, जापान का ऊपर वाला पार्ट. So this is Japan. There are 4 major groups of islands. इसके ऊपर एक और आइलैंड है. Can somebody tell me? There is a very big island here towards the north of Japan. It doesn't belong to Japan. रशिया का ही है, of course रशिया का ही होगा. किसका है? क्या नाम है बताओ. So I'll give you a hint. So वहाँ पर बहुत ज़्यादा पेट्रोलियम रिसोर्स है. ONGC is also doing exploration there by making a agreement with Russia. तो हम भी पेट्रोलियम एक्सट्रैक्ट कर रहे हैं इधर. आइलैंड का नाम बताइए, क्वेश्चन में तो यही आएगा. सकलिन आइलैंड. ओके, दिस इज सकलिन आइलैंड. ठीक है, हमेशा ऑप्शन में नहीं मिलता है, और चारों एस से ही शुरू होता है. अब बताओ कैसे मार्क करोगे? यू हैव टू रिमेंबर द नेम्स. ठीक है, सी एटलीस्ट सम ऑफ द ऑनलाइन स्टूडेंट्स रिमेंबर दिस. अच्छा है, हाँ, हमेशा कुछ ना कुछ कारण तो होता ही है नॉट टू नो, राइट? दैट्स व्हाई टेल मी समथिंग विच आई हैव नॉट हर्ड एनी ऑफ योर एक्सक्यूजेस. So there are 2 cold ocean currents here. So one comes from Sakhalin Island, another comes from another peninsula here. यहाँ पर एक बड़ा सा peninsula है. It is called as the Kamchatka Peninsula. Okay, so one was Sakhalin Island. So एक और peninsula इस बगल में, ये जो बड़ा सा peninsula दिख रहा है ना. So this is a huge peninsula. This is called as Kamchatka Peninsula. कामचटका पेनिनसुला. चलो इसका याद हो गया नहीं, एटलीस्ट सकलिन आइलैंड याद रखो, ये इंपॉर्टेंट है. सो हियर देयर आर 2 कोल्ड करेंट्स. वन इज ओयाशियो. ओयाशियो, दिस इज ओयाशियो. अनदर वन इज ओकोट्स्क. ओके, सो this is Okhotsk. So कामचटका पेनिनसुला के बगल से आता है ओयाशियो, और इस साइड से आता है ओकोट्स्क. एग्जैक्ट लोकेशन तो इतना जरूरी नहीं है, एटलीस्ट 2 कोल्ड ओशन करंट है वहां पर, ये याद होना चाहिए, इन द पैसिफिक ओशन फ्रॉम द नॉर्थ. So Oyashi comes from near to Kamchatka Peninsula. Okhotsk comes from Sakhalin Island. Sakhalin Island, and both of them merge the Kuroshio Current and North Pacific Drift near to the coast of Japan. Near to the coast of Japan. यहाँ पर आके merge होता है. ठीक है? So that is currents of North Pacific Ocean. Now the currents of South Pacific Ocean. The South Equatorial Current turns left under the influence of the landform. Okay, land इसको पूरा ऐसे घुमा देते हैं, and it moves along the eastern coast of Australia as East Australian Current. Okay, this is the same current which moves along the coast of Sydney, and it will move along the coast of Sydney, and it will join the west wind drift and crosses the South Pacific Ocean as South Pacific Drift or South Pacific Current. Okay, जब तक ये ईस्ट ऑस्ट्रेलिया के पास में था, okay, along the coast of eastern coast of Australia, it was warm current, and once it comes down and joins the west wind drift, it becomes a cold current, which is South Pacific Drift. The South Pacific Drift, along with the west wind drift, moves towards the west, and now a part of it moves towards the north and flows along the entire coast of South America. Okay, पूरा के पूरा यहाँ से ऊपर जाता है, and then this current joins back the South Equatorial Current. Now this is the very famous cold current of South America. What is the name of this? It is Peru Current or Humboldt Current. Humboldt is a very famous geographer. He himself discovered this. He is a great traveler. He roamed across the world and he made many different theories. Humboldt. Here the guy is in opposite direction. So बताइए, so north equatorial current, south equatorial current, counter equatorial current. North equatorial current turns north, and that is कौन सा? Kuroshio. Kuroshio turns right. North Pacific Drift. Warm or cold? Warm. Then that divides into two parts. One moves towards the north, that is Alaska current. Towards the south, Californian current. Two cold currents joining Kuroshio current. Oyashio Okhotsk. Okay. South equatorial current turns south, moves along the eastern coast of Australia as East Australian current, then crosses the Pacific Ocean as South Pacific Drift and turns north as Peru current or Humboldt current and joins back the South Equatorial current. South Equatorial current. Okay, यहाँ पर भी एक गायर हो गया. ठीक है? Any doubts about Pacific currents? ठीक है? Now currents of Indian Ocean. So similar to the currents of other parts of the world, in Indian Ocean again we can divide this part into the northern Indian Ocean and southern Indian Ocean. जैसे Atlantic Ocean में northern Atlantic, southern Atlantic, Pacific, northern Pacific, southern Pacific. So here the southern Indian Ocean is same as the other parts of the southern hemisphere, like the southern Atlantic Ocean or southern Pacific Ocean. But the northern Indian Ocean is totally different from the other northern oceans. Why? Because there is a huge land mass. The overall influence of land mass is very high as compared to the other oceans, and the size of the ocean is also smaller. Okay, towards the north of equator, overall amount of ocean present is smaller here. Due to the presence of huge land mass, the entire currents in the northern Indian Ocean, they totally are different from the other currents of the world in the northern hemisphere. However, southern hemisphere follow the same pattern. Southern hemisphere का same pattern रहेगा. The currents of southern Indian Ocean. Okay, first we'll discuss the southern Indian Ocean, then we'll come to the north. Currents of southern Indian Ocean. So here also we have the north equatorial current, south equatorial current and counter equatorial current. The south equatorial current turns south and hits Madagascar. Madagascar divides it into two parts. One moves towards the east, another moves towards the west. And both of them will merge back and moves towards the south. But as it comes towards the south, as it crosses 30 degrees, it will start to turn left, and then it will join the west wind drift. ये भी cold हो जाएगा. And now a part of it moves towards the north and again joins back the south equatorial current. Okay, overall circulation pattern तो यही है. यहाँ से आए, यहाँ पर डिवाइड हो गया, दोबारा ज्वाइन हो गया, वापस ज्वाइन करके दोबारा चला गया. So now this is south equatorial current. So a part of it turns south, got divided by Madagascar. One moves towards the west of Madagascar, another moves towards the east of Madagascar. Now this has a name. So that is Mozambique current. Mozambique, सुना है Mozambique? कहाँ पर है? This is the country of Mozambique. Okay, इसके कोस्ट के बगल में है Mozambique. That's why this is also called as Mozambique current. Mozambique current is between Mozambique and Madagascar. So Mozambique current will join back the other part, and now this has a name which is called as Agulhas. Agulhas current. Agulhas is the combined part. Mozambique merges with the other part, and that is the combined part is what is called as Agulhas current. इस वाले पार्ट में कोई नाम नहीं है. ठीक है? So we have Mozambique current, Agulhas current, and then joining the west wind drift and coming towards the north. This is West Australian current. That is East Australian current. This is West Australian current. East Australian current is warm. West Australian current is cold. फिर वापस चला गया. फिर यहां पर भी एक गायर आ गया. देखो पैटर्न सेम ही है. द पैटर्न ऑफ ऑल द ओशन currents across the world, it is same. Just understand the broader pattern. It is very easy to remember. You just have to remember the currents names in a sequential order. एक sequential order में imagine करो, picturize करो, तभी easy रहेगा. ठीक है? So you just try to mug up the current name. ये इसका नाम है, ये उसका नाम है, यहाँ पर ये है, यहाँ वहाँ पर इसका warm है, cold है, तो ऐसे दिमाग खराब हो जाएगा. ठीक है? Try to visualize. That is very important. That is how we can make the things easier in geography. ठीक है? So now the currents of northern Indian Ocean. So how the currents of northern Indian Ocean are different from the other northern oceans of the world. So here the most important factor which is different from the other parts of the oceans, in other oceans the winds follow a same pattern. Winds का direction change नहीं होता है, but यहाँ पर winds का direction पूरा के पूरा reverse हो जाता है. Right? So during the summers, we have the winds coming in this direction from southwest direction. That is what is called as southwest monsoon winds. During the winters, the wind direction is totally changed and it comes from northeast. So which is called as the northeast monsoon. पूरा के पूरा winds का direction ही change हो जाएगा. Okay, so we don't experience the other winds influence here. Not westerlies. Okay, westerly नहीं आता है. It is in the totally trade wind belt. And पूरा wind का direction ही change हो गया. And wind being the most primary factor, it will also influence the water circulation here. Right? So the first factor which is different from the other ocean is the winds which are not constant in the same direction. Wind का direction तो पूरा के पूरा उल्टा हो गया. The second factor is where other oceans are totally open. Okay, other oceans are totally open. It is connected with the Arctic Ocean. There is a continuous exchange of water. Here it is totally covered by land. There is a huge dominance of land. Right? There is a huge dominance of land. And the land coast, ऐसे uniform भी नहीं है. So there is too much of variation. That will totally decide the movement of ocean currents here. And that actually completely changes. There is no regular flow of ocean currents here in the northern Indian Ocean. There is a total reversal of currents also. ठीक है? So currents of northern Indian Ocean. During the winters, okay, so let me just show this as the wind direction. Okay, yellow में जो लिखा है, this is wind direction. So this is summer. Now, what is the currents? During the winter, we have the north equatorial current, south equatorial current, and then counter equatorial current. ये तीनों तो है ही. तो साउथ इक्वेटोरियल करंट ऐसे आ जाएगा, यहाँ पर डिवाइड हो जाएगा. ये तब तो हमने देख लिया इसका. ओके, ये सब तो इसका अपने जो भी है ओरिएंटेशन उसके हिसाब से चलता रहता है. एंड देयर इज नॉर्थ इक्वेटोरियल करंट. Okay, so which is flowing in this direction. What happens to the other parts of the entire northern Indian Ocean? On one side we have Bay of Bengal, on the other side we have Arabian Sea. So this entire part is under the influence of northeast monsoon winds. Okay, they are totally under the influence of northeast monsoon winds. These winds blowing the water, blowing over the water in this direction, it will also push the water in the same direction. यहां पर जो भी पानी है इस डायरेक्शन में पुश होगा, यहां पर जो भी पानी है इस डायरेक्शन में पुश होगा. सो यहां पर जो आएगा तो ऐसे जाके फिर इसको कनेक्ट कर देगा. The waters which are moving in this direction gradually forms a continuous circulation coming back and joining the counter equatorial current and moving in this direction. ठीक है? The entire water of the Arabian Sea as well as Bay of Bengal starts to move in the direction of northeast winds, causing the entire water to move in counterclockwise direction like this. तो यहां से ऐसे आएगा वापस जाएगा, यहां से ऐसे आएगा वापस जाएगा. Can you see? All the waters of the northern Indian Ocean is moving in a counterclockwise direction like this. So this counterclockwise moving current of water is called as northeast monsoon drift. So drift का मतलब था current, right? So this entire water which is moving in a counterclockwise direction under the influence of northeast monsoon is called as northeast monsoon drift. This is the situation in winter. We don't have any other currents here. Warm current. Okay, here we don't have multiple currents. It is just a continuous movement of water in a counterclockwise direction. In a counterclockwise direction. ठीक है, दोबारा बता दूंगा, ध्यान से सुनो. See, so there is only northeast monsoon. The winds are coming from land to sea in this direction, which is continuously pushing the water in this direction. This continuous movement of water will push the waters of Bay of Bengal as well as Arabian Sea in its direction. So gradually it gets connected and forms a single flow. As it comes from here to here, यहाँ से देखो ऐसे continuously ऐसा push होके इस तरफ से आ जाएगा ना. It continuously comes from this direction. It will join the counter equatorial current, and the counter equatorial current will join back this, and it continuously moves in this direction. So why? Because the overall winds are pushing it in this direction, and there is a counter current. वो तो जाएगा. So वापस आएगा, फिर इसको फीड करेगा, वापस आएगा, फिर इसको फीड करेगा, ऐसा ही चलता ही रहेगा. This continuous circulation is what is being referred to as northeast monsoon drift. ठीक है? So come to summer. The entire situation is reversed. The wind direction is totally reversed. The winds are moving from southwest to northeast direction. And compared to the northeast winds, the southwest winds are very, very strong. The southwest winds are very, very strong. क्यों? बाद में समझ आएगा. Okay, इंडियन फिजिकल जियोग्राफी में बात करेंगे इंडियन मॉनसून, तब डिटेल में समझ आ जाएगा. Okay, अभी के लिए इतना रखो. The southwest winds are very, very strong compared to the northeast winds. They are so strong, it will disrupt all the currents in the entire northern Indian Ocean. इसमें जो भी करंट है पूरा के पूरा डिस्टर्ब हो जाएगा. बचेगा एक ही करंट, दैट इज साउथ इक्वेटोरियल करंट. There is no north equatorial current, there is no counter equatorial current. It is continuously pushing the water in its direction. All the waters of the northern Indian Ocean, including the north equatorial current, including the counter equatorial current, all of it moves in its direction, causing the entire water to move in the direction of southwest monsoon winds. And this water moving here, it will come back and join the south equatorial current, and a part of it moves back here, and continuously there is a circulation as it was happening over there. यहां पर जैसे चल रहा था ना, it was happening in counterclockwise. Here it is happening in clockwise because the entire winds are moving in this direction. So it will disrupt the entire currents, and whatever is left, everything it gets pushed in the direction of these winds from southwest to northeast, and whatever the water which is going here, it will come back and through. It will come back through the south equatorial current and moves back again in the same direction. It continuously moves here, comes back. It continuously moves here, comes back. फिर opposite direction में एक drift develop हो गया, which is called as southwest monsoon drift. ठीक है? Other than this, there are no other currents here. During the summer, no other current in the northern Indian Ocean. During the winters, no other currents in the northern Indian Ocean. And these currents are different from the other currents because they are slightly weaker currents. They are not as stronger as the other currents of the open ocean. Since this is not an open ocean, and since their direction continuously changes, they are not a very strong current. This is just a general circulation. It is just a general circulation. ठीक है? Yes. ये यहां पर तो जो पानी है इस तरफ जाएगा, वहां पर पानी दूसरा कौन लेके आएंगे? ऐसे कनेक्ट हो जाएगा अपने आप. हाँ. ठीक है? इज दैट क्लियर? होता है. किसको किसको डिफ्लेक्ट नहीं कर? ये तो है ही, ये भी है, ये भी है. वैसे ही विंड इस तरफ ही आ रहा है ना. नॉर्थ इक्वेटोरियल करंट का कोई इशू नहीं है. इट इज कमिंग इन द डायरेक्शन ऑफ विंड ओनली. हाँ, ये इस तरफ नहीं जाएगा क्योंकि विंड डायरेक्शन इस साइड में है. विंड इज ए स्ट्रॉन्गर फैक्टर है ना. ठीक है? सो राइट अबाउट दिस, इसके बारे में लिखो. करेंट्स ऑफ नॉर्थर्न इंडियन ओशन. Winters. north equatorial current flows westward above the equator. Next point, counter equatorial current flows between north and south equatorial currents flows between north and south equatorial currents. Next point, the northeast monsoon drives the water of Bay of Bengal and Arabian Sea. Bay of Bengal and Arabian Sea to circulate in anti-clockwise direction as northeast monsoon drift. Next, summers. First point, the entire water of northern Indian Ocean comes under the influence of southwest monsoon producing clockwise flow of southwest monsoon drift. Next point, during this time there are no north equatorial current and counter equatorial currents. दोनों opposite, north equatorial and counter equatorial opposite direction, right? Yes. ये जो मॉनसून है वो कौन से विंड्स है? ट्रेड विंड्स ही है. हाँ करेगा. विंटर में तो कोई इश्यू नहीं था उसका. So this is a representation which shows the currents of the world. So red color में जो है उसी को ही follow करना. These are the surface currents. Blue color में जो है that is bottom ocean currents. Okay, we'll talk about that later. Okay, just follow the red color. You will get to know about all the currents. So this is north equatorial, south equatorial, counter equatorial current. You can see the south equatorial current getting divided into two branches. Okay, rest merging with the north. This is Antilles current. Okay, this is Florida current. Okay, दोनों merge हो गया. This is Gulf Stream. So Gulf Stream turns totally right after Newfoundland Island. This is North Atlantic Drift. A part moves towards the north, a part moves towards the south. Okay, Labrador current and East Greenland current joins there. So Brazilian current and then the South Pacific drift. Okay, this is, you can see, you will have the better view of west wind drift. Okay, west wind drift पूरा अंटार्कटिका को सर्कुलेट करता है. So here you will have a clear view. North equatorial, south equatorial, counter equatorial current. So this is Kuroshio and then North Pacific drift and then Florida current. Right, this is Florida current and this is cold Californian current. Alaska current, sorry. The warm Alaska current. This is Kuroshio. Okay, यहाँ पर है Kuroshio. Oyashio. This is currents of Indian Ocean. So as you can see, majorly we depict the southern Indian Ocean currents only. Northern Indian Ocean to regularly change होता है and they are not a regular currents. So this is the Mozambique current, Agulhas current, and then joins the west wind drift. So what we have discussed on the map, the ocean currents case में जो हमने discuss किया, that is the major currents. ऐसा नहीं है कि वो वहीं पे ही जाएगा. Okay, so of course a part of it moves towards the west, a part of it moves towards the east. थोड़ा बहुत तो पानी में डिस्पर्स तो होगा. वाटर फ्रॉम द अटलांटिक ओशन, सम ऑफ इट गेट्स मर्ज विद द पैसिफिक ओशन, इंडियन ओशन, तो थोड़ा बहुत तो मर्ज होता है. एंड दिस इज अटलांटिक ओशन करंट्स. ओके, सो दिस इज ब्राजीलियन करंट एंड दिस इज, ये कौन सा करंट है? बेंगुला करंट. राइट, वो सब बताएंगे बाद में. So did I show you this? दिखाया था मैंने. इसमें you can see the currents also. So you can see the overall water, the temperature of the oceans, right? So this is equatorial region, hot, then moderate, and then very cold. So can you see this around Antarctica, the waters are very, very cold, the southern ocean, and around that we have, this is west wind drift, okay, which is very, very clearly visible. Dekho west wind drift, right? So this is the cold Peru current or Humboldt current. Okay, so if you compare the surface water temperature itself, you can clearly understand. देखो cold current ऐसे ऊपर जा रहे है ना, you can clearly see the waters are moving towards the north and it gets mixed with the warm waters. So can you see here the warm current is moving here. Okay, यहाँ पर देखो Brazilian current. Okay, here you can see Benguela current. So here the red color is extending till here. That means that is the warm ocean current. Here the yellow color is extending upwards, right? The cold ocean currents. Here you can clearly see this. This is cold Canary current. Okay, so ये वाला देखो हमारा Gulf Stream, right? It's very strong at this point of time. This is ये बाहर है, इसके अंदर जाके बाहर आया था ना, this Florida current. And here you can see this Labrador current. Okay, Labrador current is here. You can see this. So this is East Greenland current. Okay, so Norwegian current देखो यहाँ तक चला गया. So can you see the same water moving towards here? Why it is called as warm? Because यहाँ पर इतना ठंडा है surrounding region में. This is warm. The same water moving towards the south, it is called as cold because here it is much higher temperature. Right? So you can explore rest by yourself. So this is the picture of gyre. This is gyre in North Atlantic, South Atlantic, North Pacific, South Pacific, and South Indian Ocean. Okay. The next part, significance of ocean currents. ठीक है. So within the tropical region, if you try to observe, okay, tropical region में जो भी ocean currents है, we can observe a pattern. The oceans within the tropical region, it always push the water from east to west in this direction. Right? It always causes the water to move from east to west. So because of this, the water is continuously moving in this direction, and this is a warm water, and there is a continuous accumulation of warm water towards the western margins of the oceans. So western margins of oceans means eastern margin of continents. Eastern margin of ocean means western margins of continents. So if you compare the eastern margin of ocean with the western margin of ocean, because of the continuous movement of water from east to west, the warm water accumulates more towards the west. Whatever the water which is there here, so it will start to move here and it gets heated up continuously and it accumulates towards the west. Gradually तो ये ऊपर नीचे चला जाएगा, but it will be there for some time. So the overall temperature of the oceans towards the western part is warmer than the eastern part. So eastern part the temperature drops. Why? because of the phenomenon of upwelling. Cold current bhi hoga, so at the same time there is also a phenomenon of upwelling. What do you mean by upwelling and downwelling? If this is the surface, if this is the, let's say this is the bottom and this is the surface waters. In some parts the water rises from bottom to top. In other parts the water sinks from top to bottom. Okay, so in some parts the water from the oceanic bottom rises upwards. नीचे से ऊपर जाता है. In other parts the water sinks from top to bottom. Causes बाद में देखते हैं. So this is called as upwelling. ऊपर जा रहे हैं upwelling. This is called as downwelling. नीचे आ रहा है. So what causes upwelling and downwelling? Let's say there is a land here. Okay, let's say there is a land here. One of the most important cause of upwelling and downwelling is winds. So if at all the land here is positioned in such a way that the winds are coming from land to sea, what do we call these kind of winds as? Offshore winds. If the winds are continuously coming from land to sea, it will push the water also in its direction. यहाँ पर जो भी पानी है, it gets pushed in this direction. The water gets pushed in this direction. So the water which is there near to the coastal region continuously gets pushed by the winds coming from the land, and that water continuously is removed. It moves towards the other parts. So there is shortage of water here. To fulfill that, from the bottom the water automatically rises upwards. Okay, the water automatically rises upward. That is what is called as upwelling. So what is the temperature of this water? Cold, because it is coming from the bottom. Upwelling water is always cold. Why the water is upwelling? Because the winds are coming offshore. It is pushing the water in its direction. So to fulfill this scarcity, मतलब यहाँ पर जो पानी खत्म होते जा रहे हैं ना, to fulfill that, the water automatically rises from bottom. That is called as upwelling. Okay, so here wherever there is some accumulation of water, where the density of water increases. Okay, where would the density of water increases? Where there is a higher evaporation, or where there is ice formation. Ice formation में होगा density. Yes. So let's say there is very cold temperature here and there is ice formation here. Ice formation will leave the salts behind and it will make the water denser. Okay, so जब ice बनेगा, salts तो पीछे छोड़ देगा ना. It will make the water denser, and this denser water will start to sink down because of higher density. Or there is also another factor. मान लो ये सब तो tropical region में हो रहा है, यहाँ पर तो कोई ice वाइस नहीं बन रहा है. And let's say this is the land here. And the same winds which are coming from here is pushing the water against the land. It is pushing the water against the land. It is making it accumulate more here. But the water, this water cannot flow over the land. यहाँ पर तो बहुत ऊपर है, मतलब land is elevation is too high. But the water is continuously accumulating. The water which is moving here, it will come and it will just accumulate. The density of water increases. It will start to sink automatically. The offshore winds can result in upwelling. The onshore winds can cause downwelling. Winds one of the primary factor. Other than that, जो ice formation था, okay, ice formation हो गया, उसके वजह से भी downwelling होगा. Okay, so there are few more things we'll discuss. In this case, in the tropical regions, कि जहाँ पर tropical regions का बात हो रहा है, where the water is continuously moving from east to west. So there is more accumulation of water. The temperature rises here since it is a warm water. But however, since there is a scarcity of water, to fulfill this, the water from the bottom upwells. It rises from the bottom. So it is a region of cold water upwelling. The temperature drops here near to the surface itself. So that is why within the tropical region, the eastern parts of the ocean is always colder in temperature than the western parts of the oceans. ये statement directly आया था UPSC में. ठीक है? So prelims का क्वेश्चन में simple statement, the eastern part of the oceans in tropical regions are colder than the western parts of the ocean. Is that right or wrong? Right? Simple है. क्योंकि they are under the influence of trade winds which will push the water from east to west. जिसकी वजह से यहाँ पर scarcity है, the water automatically rises through upwelling. Right? So now what is the implication of having warm water here? This is the region of ट्रॉपिकल रीजन है, यहां पर तो अच्छे से साइक्लोन बन जाएगा. Wherever there is a higher temperature, these regions are responsible for cyclone formations. So cyclones यहां पर ज्यादा बनता है, यहां पर नहीं बनेगा. Cyclones are usually not formed here, rather they are formed here. They form here and they move towards in this direction and it impacts this entire region. Which type of climate? This is which type of climate? China type. Okay, which is warm temperate eastern margin. They are under the influence of tropical cyclones. Why? Because the temperature of the water is higher here. Normal से ज़्यादा है because of the continuous movement of water from east to west. Okay, that is what is equatorial currents, north equatorial current, south equatorial current. That is responsible for the water to move from east to west. Right? So write about this. First point. The continuous movement of water from east to west in tropical regions causes cold water upwelling along the eastern parts of oceans, causing drop in the temperature. Next point. Accumulation of warm water along the western parts of oceans in tropical regions lead to rise in water temperature Next point. The western parts of oceans within tropical regions experience favorable conditions for the formation of cyclones. That is tropical region. So from tropical, if you come to subtropical region around 30 degrees, here we see that there is a very strong cold ocean currents. At subtropical region, along the western margins of continents, we have cold ocean currents. Right? So what is the impact of this cold ocean current? Desert formation. So why desert formation? It prevents evaporation. And it causes the air to remain dry. So that condition is called as desiccation effect. It's called as desiccation effect. That means whatever the air which is above this cold ocean currents, it remains totally dry. इसके अंदर moisture content होता ही नहीं है. So why? Normal evaporation is less because the temperature of the water is less. Since the temperature of the water is low, normal evaporation is not happening. The air remains totally dry, and being in the tropical or subtropical region, the overall air temperature is high. अगर air temperature ज़्यादा है, moisture content कम है, the air never attains saturation. That is what is called as desiccation. No saturation, no cloud formation, no precipitation. There is very less amount of moisture available in the air. Okay? So next point. The warm ocean currents, cold ocean currents. The cold ocean currents along the western coast in subtropical regions suppresses precipitation through desiccation effect. Contributing towards the formation of deserts. Example: Kalahari Desert and Namib Desert. Kalahari Desert and Namib Desert due to which current? Benguela current. Atacama Desert due to Humboldt current. Okay. So let's take a break and continue after the break. So we are talking about the significance of ocean currents. So now try to see the temperate regions. Even in temperate regions also we see a fixed pattern, where the warm currents are trying to move towards the higher latitudes, and there are some cold currents which comes and merges with the warm currents. So here the Gulf Stream is merged with Labrador current. East Greenland current merges with North Atlantic drift. Kuroshio current merges with Oyashio and Okhotsk current. Here the North Atlantic drift merges with the cold waters of the Arctic Ocean. Here the Alaska current merges with the cold waters of again northern parts. Right? So there is always the merging of warm water with the cold waters. The regions where the warm waters merges with cold waters, that is most suitable for the fishing banks, the large scale fishing banks of the world. So an unimaginable amount of fish is found here. Okay, the fishing resource is found here. They're very big scale, very large scale, and they are done in commercial manner, commercially mechanized boats. Okay, so large scale fishing is done here. So the merging of Gulf Stream with the Labrador Current happens near to the Newfoundland Island. In the same region also the East Greenland Current also merges. So here we have the world's largest fishing bank. The entire Newfoundland Island is known for the fishing activity. Okay, near here we have Grand Bank. इसका मतलब है, मतलब उसका नाम है. Okay, the local fishing bank is called as the Grand Bank. Okay, and also there is Georges Bank. Georges Bank. And near to this part of UK, there is Dogger Bank. Okay, these are the fishing banks, the fishing regions. They are called as, they are given these different names. Grand Banks, Georges Banks, Dogger Bank. Not only this, even near to Japan also. Japan is well known for fishing center. है ना, sushi, सुना है? So that is near to Japan. They are known for one of the richest fishing banks in the world. So along with the regions, so first of all, why there is, wherever there there is merging of warm and cold ocean currents, why there is a large scale fishing development? यहाँ पर ऐसा क्यों है? More oxygen and so that supports fishing growth, plankton growth. Plankton growth is required for fishing growth. Okay, these regions where the warm and cold ocean currents meet, that is rich in oxygen, nutrients, and the temperature is ideal for the large scale growth of planktons. Planktons are microscopic organisms which is the producer in the entire marine ecosystem. Okay, the food producers in the entire marine ecosystem. So wherever they are large in number, we also see the fishing growth in large scale number. In addition to this, there are many other favorable conditions which are required for the fishing growth. For example, a very wide continental shelf. Okay, shallow water body, shallow regions of water. So in this entire region, the continental shelf is very, very wide. Like that, there are many other conditions which are very helpful for the fishing growth. One of the most important one is the merging of warm and cold ocean currents, which happens here. So other than this, there is also the regions wherever there is cold ocean currents are there. जहाँ पर भी cold ocean currents है, particularly the cold ocean currents in the tropical regions and subtropical regions. There we observe a very strong upwelling because the water is moving towards the east to compensate that the bottom water also rises upwards, and under the influence of trade winds which are coming from land to ocean, it will push the water away. There is a strong upwelling. The cold ocean currents in the tropical region coming from the polar towards the equatorial region, they are very, very strong, and मतलब temperature बहुत ठंडा रहता है. They are very cold waters. In addition to the normal cold temperature, there is also a very strong upwelling is experienced here. Upwelling happens from the bottom. As the water rises from the bottom, it is very rich in terms of nutrients. Why? Oxygen? Why the upwelling water is rich in nutrients? Bottom of the sea. What is bottom of the sea? What will be there? Sediments. Sediments से तो nutrients नहीं आएगा, खाना तो नहीं आएगा उससे. Not from magma. बताइए पीछे से तो आंसर आता ही नहीं है. बताइए. You can be louder, yes? Anyone? Somebody was saying. Why the upwelling water brings good amount of nutrients? ठीक, ओशन बॉटम में तो कोरल रीफ नहीं रहता है ना, तो बताइए. It is due to the presence of dead and decaying organic matter along the bottom. Whatever the life in the ocean, once it dies, what happens to them? It will all sink to the bottom. सब नीचे ही गिरेगा. All the dead matter, all the decaying organic matter is all there in the oceanic bottom. When the water rises upwards, it brings all that matter, organic content, which is rich in nutrient. Okay? So that is required for the fish growth. Upwelling brings that nutrients from the bottom. ठीक है? Overall oceanic currents का significance यही है in the context of fishing sector. So wherever there is a merging of warm and cold ocean current, wherever the warm water are entering into the regions of cold waters, or wherever there is a cold water upwelling, they are all very good for fishing growth because they are very rich in terms of nutrients. So one of the largest fishing banks are located here. Write about this. Warm and cold ocean currents merging near temperate regions, create favorable conditions for the development of large scale fishing banks. Example: Grand Bank near Newfoundland Island. Due to the merging of Labrador current with Gulf Stream. Next point. The offshore winds along western margins of continents in tropical and subtropical regions. Push the surface water away. And cause the cold water from the bottom to rise upwards to the surface. Stop. This brings cold and nutrient rich water cold and nutrient rich water to the surface through upwelling. The regions of upwelling support large scale fishing growth. Example, Humboldt current. Along the coast of Peru and Chile. Humboldt current along the coast of Peru and Chile. So you know these two countries, Peru and Chile, major part of it is totally desert. Okay, one of the driest, the Atacama Desert is the driest desert in the world. That is located here. Okay, यहाँ पर है. So because of the same reasons which we discussed earlier, 3 reasons: offshore trade winds, nearness to subtropical high pressure belt, and cold ocean currents. So here this is the driest desert in the world because the Humboldt current is a very strong cold current. It's because of its impact. The precipitation is totally suppressed. And during the normal conditions, here there is no precipitation at all. Okay, so there are records where for continuously 4-5 years there is no single drop of rain in this desert. It is the driest desert in the world. Okay, so how about the economy of this Peru and Chile, and on what basis they would survive? Pura ke pura dry hai. Large scale fishing. The Humboldt current being a very strong cold current, it brings a very strong upwelling, and that supports a huge growth of fish. Unimaginable amount. बहुत large scale में होता है. And through fishing, it supports the entire economy. Fishing is a major economic activity over there. And other than fishing, there is also another important activity which is a source of income over there. To feed on the fish, birds come in large number. Okay, birds. There are large different variety of birds. Okay, guano, cormorants, and various other birds. They come in large number, and they make a huge colony on these deserts near to the coastal region. Okay, daily they go out into the ocean for fishing. Okay, they just eat fishing and they will come back. They make a huge nest, huge colony. Just they sit on the land. The bird droppings which are there in this entire region, the bird droppings which are produced by this entire huge colony. So these are migratory birds. When they migrate out, the people will just collect it and they produce fertilizer from this. This is one of the largest source of phosphatic fertilizer in the world. Other than fishing, fertilizer industry is one of the most important part of their economy. Okay, so that is due to the Humboldt current. Okay, next topic में आएगा El Nino. Okay, so we'll discuss about that El Nino. El Nino is a situation where this current is disrupted. Cold current disrupt हो जाएगा, warm current आ जाएगा, तो उसके वजह से पूरा यहाँ पर collapse हो जाएगा economy. ठीक है, we'll talk about that. So that is Humboldt current, the role of Humboldt current. So other than this, बाकी सारा जो अभी तक बात हुआ है बताइए, कहाँ कहाँ पर बात किया था ओशन करंट के, सारा लिख लेते हैं एक ही जगह में. Where all did we discuss about the ocean currents? डेजर्ट तो हो गया. कहीं पे बात नहीं किया था हमने ओशन करेंट्स के बारे में? वेयर डिड वी डिस्कस अर्लियर? जेट स्ट्रीम्स में ओशन करेंट्स का बात किया था? नहीं। प्रेसिपिटेशन में कैसे? सप्रेशन ऑफ प्रेसिपिटेशन हो गया। टेम्परेचर डिस्ट्रीब्यूशन में बात किया था। इट हेल्प्स इन डिस्ट्रीब्यूशन ऑफ टेम्परेचर अक्रॉस द वर्ल्ड। ओके, सो देयर इज अ ग्लोबल डिस्ट्रीब्यूशन, टेम्परेचर डिस्ट्रीब्यूशन मैकेनिज्म में था। नॉट ओनली द ग्लोबल टेम्परेचर, इवन द ओशनिक टेम्परेचर ऑल्सो, दोनों जगह में बात हुआ था। यस, इट्स अ वेरी इंपॉर्टेंट चैनल ऑफ टेम्परेचर डिस्ट्रीब्यूशन विदाउट विच there would be global temperature variation. The tropical region starts to become too hot, the polar region starts to become too cold. There will be imbalance. Okay, heat budget, heat imbalance हो जाते हैं horizontal direction में। ठीक है, लिखो next point. Not only temperature, salinity भी, it helps in distribution of salinity, right? Ocean currents help in global distribution of temperature and salinity. जो बात किया था बताइए, इतना ही याद है। साइक्लोन का तो हो गया, थर्ड पॉइंट लिखा था साइक्लोन। वेजिटेशन कैसे? फ्रंट्स में ओशन करेंट्स का रोल नहीं है। ब्रिटिश क्लाइमेट का बात किया था, लिखो। The warm ocean currents in temperate regions along the western coast of continents result in mild winters and keep the ports ice free. Example, North Atlantic drift along Britain. और बताइए। सेम ही है एग्जाम्पल, दूसरा पॉइंट बताइए। इट इज ऑल्सो हेल्पफुल इन नेविगेशन, राइट? तो हमारा नीमो को बचाया था। देखो, इट कैन बी यूज्ड इन नेविगेशन, इट इज यूज्ड इन नेविगेशन। यस, ओशन करेंट्स can be used in navigation to find direction in open ocean. ठीक है, हो गया 10 पॉइंट हो गया ना, काफ़ी है। नो है, कौन सा मिसिंग हो गया? हाँ, फॉग फॉर्मेशन कैसे बनता है बताइए। सो वेर एवर द एयर नियर टू द सरफेस कूल्स डाउन, okay, that results in the formation of fog. The meeting of warm and cold ocean currents also result in the formation of fog. It is a type of advection fog. So above the warm ocean current, the air is warmer and rich in moisture content. Above the cold ocean current, the air is cooler and it is very, very dry. When both merges, the air gets mixed up. the temperature of this warm air cools down, and because of that cooling down, condensation happens and there is a fog formation. ठीक है? It is because of the merging of warm and cold ocean currents, there is fog formation, and fog formation will disrupt navigation. टाइटैनिक वहीं पे इसलिए है ना, अभी भी ओशन के अंदर ही है. इट वांटेड टू रीच यूएसए. ओके, सो यूके से स्टार्ट किया था, यहाँ तक आके आके डूब गया. क्यों? यहाँ पर ही एक्सीडेंट क्यों हुआ था? आइसबर्ग्स भी है. आइसबर्ग्स क्यों यहाँ पर है? वहां से आया था, वहां पर कहीं पे भी नहीं मिला था आइसबर्ग. यहाँ पर क्यों मिला था? कोल्ड ओशन करंट है ना. आइसबर्ग दिखा नहीं क्यों? लाइक व्हाई वाज इट नॉट विजिबल? फॉग फॉर्मेशन. फॉग फॉर्मेशन यहाँ पर ही क्यों था? बिकॉज ऑफ मर्जिंग ऑफ गल्फ स्ट्रीम विथ लैब्राडोर करंट. द कंडीशंस आर फेवरेबल फॉर fog formation. Right about this? The merging of warm and cold ocean currents result in fog formation. Which may obstruct ocean navigation. So that is about significance. So next subheading, upwelling and downwelling. So till now we have discussed about surface currents. Okay, surface currents is just a movement of surface water. Surface waters continuously move from one part of the ocean to another. It helps in distribution of temperature and बाकी सारा impact तो हमने बात कर लिया. So the entire ocean, is it just the movement of surface waters? So what about the bottom water? Is it not moving? So there is movement of bottom water also, but they are moving very slowly. So is the movement of bottom water and surface water totally different from each other? No, both are connected. Okay, both are connected through the zones of upwelling and downwelling. So that is how they are connected. The bottom water moves very slowly. It moves very, very slowly. ठीक है? Surface water moves faster. फिर भी over at the global scale, if you see, they both of them are connected. They are not required to move at the same speed. Now, so what is upwelling? The rising of the water from the bottom is upwelling. What is downwelling? The water from the surface moving downwards is downwelling. So what causes upwelling? Okay, one of the most important cause हमने discuss किया, offshore winds, which will push the water away from the coast, and to fill the gap, the water from the bottom rises automatically upwards. So what causes downwelling? Onshore winds causes the water to accumulate more. It becomes denser and will start to sink down. Other than this, downwelling also happens in the regions where warm and cold ocean currents meet. Wherever warm and cold ocean currents meet, what happens to these currents? It behaves in a similar manner as that of air mass. थोड़ा बहुत mix up होगा, but a major part of the cold current starts to descend down because it is denser. Okay, it will start to descend down. That is what is downwelling. Okay, downwelling also happens in the regions of ice formation. Wherever there is ice formation, the water becomes denser due to the salinity increase. है ना, salt accumulation की वजह से denser हो जाएगा, फिर it will start to downwell. So like this, there are different parts of the world where there is upwelling, where there is downwelling, तो continuously चलता ही रहता है. So these are the links. The upwelling and downwelling are the links through which Both the surface currents and the bottom currents are connected, and it keeps the entire water of the oceans continuously in a circulation mode. So continuously circulation में रखता है. That is what we call it as the oceanic circulations. Okay, oceanic circulations बोलते हैं. So what do we call the bottom ocean currents as? Thermohaline circulations. इसका नाम है thermohaline circulation. ठीक है, right over this. Downwelling and upwelling. First, downwelling. First point. The onshore winds pile up the water near to coast. Causing sinking of water below the surface layer. Next, upwelling. The offshore winds push the surface waters away. Offshore winds push the surface waters away and causes the cold water from the bottom to rise up to the surface. Next point. Upwelling is more active in the regions of cold ocean currents. Next point. Downwelling is more active where warm and cold ocean currents meet. Next point. In polar regions, ice formation leaves the water saltier. And denser. Causing it to sink. Next subheading, thermohaline circulation. So I told you, surface currents, it covers just 10% of the ocean. The rest 90% of the ocean is the water which is there below the surface, and they are not part of the surface currents, and they are part of a deeper water current, deep ocean currents. The name of this deep ocean current is what is called as thermohaline circulation. इसी को ही thermohaline circulation बुलाते हैं. So there are many differences between the deep ocean current and the surface currents. Okay, so let's understand the difference, then you will get the better clarity about this. पहले difference है surface currents, they are in the top layer only, maximum up to 400 meters. Okay, thermohaline circulation is bottom. Bottom means not completely below, the entire waters below that. Okay, 400 meters छोड़ के बाकी सारा तो जो भी पानी है वो continuously move होता है. That is what is thermohaline circulation. Second, surface currents are of both the types, warm and cold current. Thermohaline circulation is majorly cold. Okay, so it is majorly cold because it is bottom current. Surface currents move faster. Thermohaline circulation moves very, very slow. It moves very, very slow. The surface currents, they are majorly driven by winds. Here there are no winds. Winds तो होगा ही नहीं. Then what is causing this bottom currents to move? The differences in temperature and salinity. The differences in temperature and salinity is causing the water to move. That is why it is called as thermohaline. Thermo means temperature, haline means salinity. The difference in temperature and salinity in different parts of the world causes the water to move from one part to another. Because of that difference, okay, that will push the water, right? So that generates the currents, and that is why it is called as thermohaline circulation. The general difference is, we all know, the tropical waters are higher temperature, polar waters are lower temperature. Tropical waters are higher salinity, polar waters are lower salinity. So this difference triggers the water to move along the ocean bottom. So the surface currents are driven by winds, thermohaline circulations are driven by difference in temperature and salinity. The surface currents, so they are, even though they form a continuous pattern, but the surface currents of different oceans are different. So we have discussed in detail about the surface currents of North Atlantic Ocean, South Atlantic Ocean, North Pacific Ocean, South Pacific Ocean. ये सब अलग-अलग discuss किया. There are no different thermohaline circulation. There is only one thermohaline circulation, which covers all the ocean as a single current. ये एक ही current है. The bottom current, there are no different currents. It is a same current which is moving all across the different parts of the world, because all the waters are of same characteristics. And since they are moving very slowly and continuously in different parts of the world, all of them are connected into a single belt kind of structure, resulting in a great conveyor belt of ocean. What is a conveyor belt? जो एयरपोर्ट में देखते हैं, जिसके ऊपर सामान आता है ना, conveyor belt. In the same way, there is also a huge conveyor belt which is continuously moving from one part of the ocean to another part. And here we can clearly see the connection between the bottom water and the surface currents. कहाँ पर? Through the zones of upwelling and downwelling. Near to the polar region, the formation of ice makes the water denser. There it starts to sink. The merging of warm and cold ocean currents causes the water to sink, and then it will push the water. जो नीचे जा रहे वो कहाँ जाएगा? नीचे तो ऑलरेडी पानी है, ऐसा नहीं कि नीचे तो जगह खाली है ना? So already water is there. If the water is going downwards here, it will push the water somewhere upwards. है ना? वो अपने आप ऊपर आएगा. That is what is the zone of upwelling. Here it is zone of downwelling. ये दोनों connected है across different parts of the world. There are different zones of downwelling, different zones of upwelling. Because of the difference, the water of the ocean bottom continuously moves. Right? So that is how the upwelling and downwelling zones connects both the surface water and the bottom water. And this plays a very important role in the distribution of the temperature of the global oceans, temperature and salinity of global oceans. And it is because of this there is a maintenance. Okay, there is a maintenance of temperature and salinity. If any part of this gets disturbed, अगर कोई एक part disturb हो गया, it causes catastrophic impacts, large scale impacts. The way recent report of IPCC has suggested. ठीक है, so उसके बारे में बात करते हैं. First write about this thermohaline circulation. Thermohaline circulation. First point. The deep ocean currents, driven by differences in water density which is controlled by the temperature and salinity is called as thermohaline circulation. It's called as thermohaline circulation. Next point. The circulation begins near polar regions. Of downwelling. Where ice formation leaves the water saltier and denser, leading to sinking. Next point. This underwater current moves in a single and continuous belt. Across different oceans. Next point. They are connected to surface water currents. In the regions of upwelling. Next point. They are also called as Great Ocean Conveyor Belts. So वो जो वीडियो दिखाया था पहले, उसमें बॉटम वाला पार्ट था ना, ब्लू कलर, दैट वाज द थर्मोहालाइन सर्कुलेशन. So now we can observe the bottom part. Blue color में जो चल रहा है, that is the thermohaline circulation. It continuously move from one part of the ocean to another part. So it will not follow the same path taken by the surface currents. It is not necessary that it has to follow the same path. It will have its own path. Sometimes it follows, sometimes it will not. देखो यहाँ पर downwelling हो रहा है ना, वो नीचे जा रहे हैं यहाँ पर. And that is joining the thermohaline circulation. You can see there is also this part around Antarctica. Antarctica के surrounding में भी है thermohaline circulation का part. And उसका अलग अलग branches है. One part of it moves towards Indian Ocean, another part moves towards Pacific Ocean. And there it joins the downwelling somewhere else. यहाँ पर जाके कहीं पे upwelling होगा. So now if you see this part of this thermohaline circulation, so I told you this same circulation goes across the entire earth and all the oceans are covered. The thermohaline circulation is there majorly, like one of the largest part of this circulation is in Atlantic Ocean. Right? This is in Atlantic Ocean. And here ये जो red color में दिया है, this is the surface water, you can see this is the Gulf Stream and North Atlantic Drift. Here it is going and merging. फिर वो cold water आएगा, यहाँ से नीचे से जाएगा, ये पूरा चल रहा है. So this part of the ocean currents in Atlantic Ocean, okay, it is the part of the ocean currents in Atlantic Ocean covering both the bottom current as well as the top current. This part of the ocean circulation in Atlantic Ocean is called as Atlantic Meridional Overturning Circulation. बताइए, Atlantic Meridional Overturning Circulation. Okay, it is in Atlantic Ocean. That is why Atlantic meridian, because along the longitude wise है. Okay, meridional overturning, मतलब ऊपर से आएगा नीचे से आएगा फिर ऊपर से आएगा, ऐसे overturning circulation. Along the meridian in the Atlantic region there is a overturning circulation. So this part of the thermohaline circulation is called as Atlantic Meridional Overturning Circulation. This is a very important system of the global climatic control. It is like a control system of the global climate. See, the major factor behind the ocean circulation is the coastline, the way continents are distributed. Imagine how the ocean currents would be there during the time of Pangea. कैसे हो सकता है? पूरा टोटली डिफरेंट होगा, राइट? So the land is different, the contents are different, the overall orientation itself would have been different. There was a single ocean, right? So the present ocean currents are the pattern due to the present position of the continents. Is that right? And these ocean currents, they help. One of the most important significance of this is distribution of temperature between the equatorial region and polar region. It carries the warm water here and brings the cold water here. It helps in removing the excess heat from the tropical region. It helps in keeping the polar regions slightly warm. अगर ये mechanism नहीं है तो polar regions becomes very very cold. The tropical regions become very very hot. The latest report of IPCC. What is IPCC? Intergovernmental Panel. Okay, Intergovernmental Panel on Climate Change. It is a research body. It is a research body which has provided the evidence that whatever the climate change which is happening is due to human induced factors. Okay, man made factors के वजह से ही climate change हो रहा है, ऐसा बोल के यही body evidence लेके आया था. Even in fact IPCC has also got Nobel Peace Prize. ठीक है? So now one of its recent report has suggested that AMOC is weakening. The strength of AMOC is weakening. Okay, now comes the two parts. One is why it is weakening, what are the impacts of the weakening. So why it is weakening? Because of the global climatic change. Okay, the positions of continents are not changing. Of course, if it changes, definitely the overall current direction would change. Right? So keeping the position of the continents constant, if at all the ocean currents are changing their nature, it should be definitely due to the climatic conditions. How? See, the way I told you, the currents help in distribution of temperature. At the same time, temperature also helps in generation of current. First of all, there is a difference of temperature between the polar region and the tropical region. There is cold water here. There is warm water here. This temperature difference is a main factor which will pull the water towards that direction. Among the factors which will help in the oceanic current generation. Okay, so first the wind tha, second tha differences in temperature and salinity. The difference in temperature will pull the water in that direction. Due to the global warming, the difference is decreasing. Polar regions are also becoming warmer. Tropical regions are anyway warmer. The water temperature is almost similar. Why would the water move from here to there? The global warming and climate change is basically weakening this AMOC, weakening of Atlantic Meridional Overturning Circulation. It is majorly due to the global warming, the impacts of global warming. Now what is the effect of this? Various different effects. On the surface of Earth we have different critical points, tipping points. Okay, tipping point matlab once we cross that point there is no coming back. Once we cross that point there is no coming back. For example, Amazon rainforests. If the entire Amazon rainforests are burnt, if we lost this entire part of this, it will have a huge catastrophic impact. The biodiversity is lost. The huge amount of carbon which is stored in the forest, that is lost. है ना? So इसका impact तो बहुत ज़्यादा हो जाता है. उसके बाद में उसको वापस नहीं ला सकते. Even if you grow forest, even if you do afforestation, कुछ भी करो, वो वापस नहीं आएगा. The impacts will have a result which is irreversible. Like that. The weakening of AMOC is such tipping point. Once it becomes weaker, it will trigger a series of changes in the oceans as well as on the land, which is irreversible. Okay, पूरा irreversible हो जाता है. तो इसके ऊपर बहुत पहले, I think 10-20 साल पहले एक मूवी आया था. Okay, so the day after tomorrow. Okay, so it starts with the weakening of North Atlantic drift. ठीक है, so उसमें तो बहुत हाइपोथेसिस करता है कि बोलता है कि बहुत ज़्यादा बड़ा बड़ा साइक्लोन्स आ जाएगा and it triggers freezing condition. बहुत सारा हाइपोथेसिस है. Okay, so these are all hypotheses. They are not even theories. ठीक है, हो सकता है, पॉसिबल है. So, but if at all the thermohaline circulations are disturbed, particularly this Atlantic meridional overturning circulation is disturbed, so definitely it will disturb the temperature distribution which is happening. The Western European countries will start to freeze. Okay, polar region is overall its temperature is rising, but this region is already warm because of the under the influence of North Atlantic drift. Now it will start to become cooler. Right? So even they will start to experience frozen ports, right? And the warm water which was continuously moving over there, it will start to remain backwards, मतलब यहीं पे रहना शुरू करता है. It will start to remain here. That will cause more stronger cyclones, more frequent cyclones. Because of the accumulation of water in this part, since it is not moving over there, it will start to accumulate. Trade winds to continuously push कर ही रहे. The water is not moving upwards. Because of this, there is a rise in the sea level here. It may submerge many of the coastal regions, right? And most importantly, it will disturb the entire marine ecology, the fishing growth, the phytoplankton's growth, the marine migration, everything is totally disturbed. All of them are dependent upon the entire thermohaline circulation as well as the surface water circulations. Right? So, it will definitely have a catastrophic impact. इसका chain reaction एक दूसरे के ऊपर ऐसे होता है. So, one of the impact is that the global warming is triggering the disturbance of the ocean currents, and the disturbance of ocean currents will disturb the temperature distribution. And once it happens, the polar region starts to become very, very cold. The tropical region starts to become very, very warm. And the colder temperature of polar regions may also trigger ice age. हो सकता है, right? So it's a chain reaction, possible है, right? So ऐसे. So its impacts are going to be irreversible. So IPCC ने बोल दिया कि ये तो शुरू हो गया है. Yes, the Atlantic meridional overturning circulation has started to become weaker. ठीक है? So इसलिए इतना बहुत बातें होता है. COP, Conference of Parties to what? UNFCCC, United Nation Framework Convention to Combat Climate Change. है ना, हर साल मिलते हैं. इस साल कहां पर मिले थे? इजिप्ट में मिले थे, शर्म अल शेख, राइट? ठीक है. सो वहां पर यही बातें होते हैं. तो क्लाइमेट चेंज को कैसे कंट्रोल करना है, ग्लोबल वार्मिंग कैसे कंट्रोल करना है. सो बहुत लोग इसको मानते भी नहीं है. दे डोंट इवन अग्री दैट क्लाइमेट चेंज इज हैपनिंग. सो बिफोर इट्स टू लेट वी शुड रियलाइज, राइट? सो देन देयर इज नो कमिंग बैक. इफ यू आर इंटरेस्टेड यू कैन वॉच दैट मूवी, यू विल अंडरस्टैंड. सो क्या होता है, ठीक है? सो राइट अबाउट दिस Atlantic meridional overturning circulation. Atlantic meridional overturning circulation. In the bracket AMOC. AMOC is a part of thermohaline circulation. A part of thermohaline circulation in the Atlantic Ocean. In the Atlantic Ocean. Stop. The recent report of IPCC, talks about the weakening of AMOC due to global warming. Next subheading, factors responsible for weakening. Factors responsible for weakening. First point, the temperature difference between tropical and polar regions is decreasing due to warming of the Arctic region. Next point, this weakens the North Atlantic drift. Next point, the excessive addition of fresh water due to increased melting of ice. Excessive addition of fresh water due to increased melting of ice in polar regions. Reduces downwelling as the fresh water is less dense. ये वाला पॉइंट समझ आया? See the thermohaline circulation, I told you it is connected with the surface circulation. Surface जितना strong रहेगा ये भी continuously move होगा. And both are connected through upwelling and downwelling. अगर downwelling disturb हो गया तो upwelling भी disturb हो जाएगा, फिर thermohaline circulation भी disturb हो जाएगा. So near to the polar region, the continuous melting of ice, it adds fresh water. The overall amount of fresh water is increasing. Fresh water is lower in density than the salty water, okay, marine water. So that will not undergo downwelling. वो ज़्यादा downwelling नहीं होता है. In fact, it will suppress the downwelling which is already happening over there. अगर downwelling disturb हो गया तो thermohaline circulation भी disturb होगा, right? Impacts. Next point. First point. The Western European countries will experience harsh winters. And frozen ports. Harsh winters and frozen ports. Next point. The western parts of oceans in tropical regions experience a rise in sea levels. Next point. Increased occurrence of cyclones. In tropical waters. Next point, disturbance of fishing zones. Next point, disturbance of marine ecosystem. So next subheading, water mass. Water mass. So we have discussed about air mass. Air mass क्या था? A section of air with uniform temperature, uniform humidity, okay, overall uniform characteristics. The same manner, okay, so a section of water with uniform temperature, uniform salinity. Temperature salinity तो same नहीं होगा ना. So overall we have seen the distribution of temperature and salinity. Wherever there is a uniformity, it attains that a single section, एक cross section single हो जाते, एक uniform mass type जैसे बन जाते, that entire section of water is called as water mass. Okay, that entire section of water is called as water mass. So very similar concept to air mass. जैसे air mass था वैसे ही water mass है. Uniformity of temperature, uniformity of salinity. So जैसे air mass एक दूसरे से mix नहीं होगा, वैसे भी ये भी mix नहीं होगा. So जैसे air mass it tries to maintain its uniformity of characters, it will not undergo change. ये भी ऐसा ही uniform रहता है. There are three types of water masses depending upon the height in which they are existing, the depth in which they are existing. The water mass which exists near to the surface, they are surface water mass, intermediate water mass and deep water mass. Which one is the most common water mass? जो हर जगह में मिलेगा? Deep water mass. क्योंकि deep में क्या है? So हर जगह में same ही है, cold temperature, higher salinity. Okay, 35 parts per thousand का uniformity तो रहेगा हर जगह में. So you will find deep water mass in every part of the ocean. Atlantic Ocean, Pacific Ocean, Indian Ocean, Southern Ocean, हर जगह में मिलता है. Surface water mass is available on only that part of the ocean where there is some stable condition, some uniform conditions. ज़्यादा regular disturbance नहीं होना चाहिए. Right? So intermediate water mass in the intermediate level like that. So what is the significance of these water mass? They are one of the very important reason behind the formation of thermohaline circulations. Since there is a difference of characteristics between the surface water mass and bottom water mass, deep water mass, that difference in the characteristics will cause the water to move up and down. That is what is triggering upwelling and downwelling. Surface water mass being near to the surface, it is slightly warmer, lower in density. Deep water mass, slightly cooler, higher in density. There the higher evaporation, if it causes higher salinity, density increase हो जाएगा. इससे अगर इससे भी ज़्यादा increase हो जाएगा, फिर नीचे आना शुरू हो जाता है. Wherever there is a difference, that will trigger the water mass to move from one part to another, right? The way air mass was moving from one part to another due to the difference in temperature. In the same way, difference in temperature and salinity causes the water mass to move from one part to another. So that actually generates not only upwelling and downwelling, it is also responsible for the formation of the entire thermohaline circulations. The entire thermohaline circulations, their generation and their movement is depend upon the existence of water mass. अगर एक जगह में ऐसे जो water mass है, it is slightly lower in density, दूसरी जगह में higher in density, there is a tendency of movement between them. If everywhere it is uniform, why would the water move? Right? So other than that, by providing uniform conditions, they are responsible for certain phenomena. For example, surface water mass, by providing uniform conditions near to the surface, they may also help in generation of tropical cyclones. It provides that uniformity of conditions, right? There is no rapid change. Tropical cyclones के लिए क्या चाहिए? We need uniform conditions, uniform high temperature. If it becomes too hot, शायद it will also provide the uniformity required. The same goes with the coral reefs. Coral reefs maintain, they want that uniformity of condition. They don't want the continuous change, rapid change नहीं होना चाहिए. Not only that, even the plankton growth also. The large scale growth of plankton depend upon these favorable conditions. and that should exist uniformly for a longer period of time. That is possible in water mass, right? The similar concept of air mass you apply to the water, you will find water mass. Okay, write about this. We cannot consider current as water mass. Current is different. Currents, particularly the surface currents, are triggered by water mass. We can say so. The warm water mass near to the tropical region and the cold water mass near to the polar region may cause the water to move. The difference of temperature, difference of salinity will pull the water in that direction. But the moving water, we cannot call it as a water mass. Okay? So water mass is like air mass. Can we call moving air mass as wind? No. So जैसे planetary winds था वैसे हमारा surface currents है, जैसे air mass है वैसे water mass है. It is a body of water. It is a body of water with uniform characteristics. With uniform characteristics of temperature and salinity. Of temperature and salinity. Stop. They are of three types. Surface water mass, example, Antarctic surface water mass, second one, intermediate water mass, example, subtropical intermediate water mass, subtropical intermediate water mass of Atlantic Ocean. Deep water mass, third one. North Atlantic deep water mass. Next point. Water masses help in generation and maintenance. Help in generation and maintenance of thermohaline circulation. Thermohaline circulation. Next point. They result in upwelling and downwelling. They result in upwelling and downwelling. Next point. The movement of water mass, help in distribution of temperature, salinity and oxygen. Next point. The uniformity of conditions within water mass supports plankton and coral growth. Plankton and coral growth. So that is all about oceanic circulations. We have discussed surface currents, the different types of surface currents, significance of surface currents, thermohaline circulation, and then water mass, and all the things related to this, both prelims and as well as mains. In the next class, we'll be talking about another very important part of oceanography, that is El Nino. El Nino and all the related phenomena. Okay, thank you.